spend like 10 minutes finishing up on yesterday's hard problem. I did come up with a solution for it and I submitted it like before the deadline, but just gonna do a summary of what happened. Um, the work for it is on the previous video, but the basic premise I had was the same. So basically you have a line of robots and some walls between them or on them at those positions, and you're supposed to have the robots fire either left or right of them. Each robot has a certain distance that the bullet that they fire can go to, and it will pierce or destroy any walls that crosses within that distance. Also capped by the next robot in that direction. So if there's like a robot, two walls, and another robot, then the second robot can only pierce the two walls to the left of it. It can't pierce past the robot at the left. Vice versa, the first robot can only shoot the two walls to the right and can't pass the robot after that. So a few things here to simplify things. One kind of edge case is where the robot stands on top of the wall. So that wall will always be destroyed because regardless of whichever direction the robot shoots, it's gonna hit that wall. It's explosive. So I basically remove those walls from consideration. So I create the set of robots, and auto is the count of the walls that are automatically destroyed because they're in the same position as the robots. That's just a variable. And then I'm going to create a new array called diff walls for the walls that are different from the position of the robots. So every wall in the walls array, if the position of that wall is not the position of the robot, then it's going to be like a unique wall, a different wall to the robots. And then the difference between the original walls, number walls, and the number walls that are different than robots is going to be the ones that are obviously on top of the robots, so therefore they're automatically destroyed. And then I make the walls array just the walls that are removing those, destroyed. Then I sort the walls and I append to infinity. Append infinity just so it's a backstop because I want to at some point iterate over the walls index, the walls that erase with an index, and I don't want to go infinite. Left, right are just constants 0 and 1. So the original information with the robots are a certain position, and each robot at that same index has a certain distance. So for instance, index 0 has robot 4, or has robot position 4 and distance 3. So this means the robot can shoot 3 to the left and 3 to the right of 4, which is like 1 through 7. Obviously, you kind of want to sort it, so I made a tuple based on the robots and the distance associated with each index, and then I sort it, so it's now sorting by position. And this would generally be good. Actually, did I ever use info after this? Yeah, I did. Sorry. So once I have the positions of the robots and their distances, then what I want to do is I thought to convert it to a range of values. So for each robot, I'm going to create a tuple that is the left bound of the robot, the position of the robot, and the right bound of the robot. So that's their kind of effective range of their shot, I guess. You can think of it. So yeah, this is this code, basically iterating over all the indices, robot indices, and then the left bound is going to be like one position past the last position robot, the position of the last robot plus 1, right? Or the current robot's position minus delta, where delta is the shot distance. The top of the pin has the position of the robot, and then similarly the position of the next robot minus 1, or position is delta. So from there, I originally considered making a DP matrix where the dynamic programming matrix, you generally think about the state. Here the state would be based on the robot that you're dealing with and whether or not that robot fires left or right. And then the state value is either is particularly the number of walls that were destroyed at that state, and then also storing information about the last wall index, just to track that. Originally it was going to be a matrix. It was going to be like a 1D array, or the 2D array, sorry, 2D array. The index of the robot is the first dimension, and then left-right is the second dimension, whether or not they fire left or right. And then, but instead of storing a single value there, it stores a tuple value. So state value is the number of walls stored, rather, yeah, stored, and the index, the last wall. So eventually I changed it into just you don't need to keep track of the whole 1D array, you just need to keep track of the last state of, so disregard the index part, the robot index part. So anyway, so set up for the first wall, keep track of the wall index, get the left position and right, kind of the range of the first robot, and then skip the walls that are too far kind of below the left bound of the first robot. When here's the wall index. At that point, you should be at a wall index that is kind of hopefully within the left bound of the left side shot of the first robot. So you increment that wall index as long as it's within the left and the position of the robot, and then increment the left destroy that counter. And so here current is the substitute for the DP matrix. It's just current values for the left and right. So current at left, which is just replacing the 0 here with the tuple that is the left number of walls destroyed, and the wall index where it kind of stops. At that point, you should be moving on to the wall index, or the walls that are being destroyed if the robot shoots right, if the first robot shoots right. So while position is less than wall index, less than equal to right, increment the number of right walls destroyed, increment the index, and then the current kind of state values for the right side is the number of right walls destroyed and the index that it stops at if it shoots right. And then every time here is I'm just going to say previous equals current, and then current will be updated. So then you have the main loop, iterate over your indices of kind of everything past the first robot. And if you really think about it, there's like kind of four scenarios. Basically, if you think about the first robot shooting left or right, if the first robot shoots left, and then the next robot shoots left, and the first robot shoots right, and the next robot shoots left, or the first robot shoots left, next robot shoots right, first robot shoots right, next robot shoots right. Those are kind of the four scenarios for every kind of consecutive robot shots. So if it's something like the left-left shot, right, these two shots are not going to be overlapping in the walls that are being destroyed, and the number of walls that are destroyed from this robot shot is going to be just strictly added with the number of walls between those two robots. So for instance, if you have, let's say, wall, robot, wall, 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 robot, let's say wall, wall, just ignoring the range for now. So like this first robot shoots left, it's going to destroy this first wall, say wall, wall. And then if the second robot shoots left, then it's going to destroy maybe wall 2, wall 3, wall 4. So kind of increasing the count of the left destroyed walls here with the middle walls will get you the number of walls destroyed by the right. One possible number of walls destroyed by the right if the ship's left. So while iterating over the indices of the robots, we get the left position and right range of the current robot. We get the maximum number of walls destroyed if the last robot shoots left, and the index of the last wall that they shot left with, and similarly for the right, for the last robot. And then we move the wall index so that it's at the leftmost position of the current robot. And then this is now going to be considered the middle walls that are being destroyed between two robots. If the current robot shoots left. And while the current wall position is in the left range of the current robot, then I'm going to consider this the count of middle walls that are destroyed. And that's pretty much it for that. At that point, it's going to so that's one count, the middle count. The other issue is if the first robot shoots right, and then the next robot shoots left. This is kind of one kind of overlap case, right? Because there could be walls that are shot by the last robot shooting rightwards, and then that are also being shot at when the current robot shoots leftwards. It's kind of like overlapping. So for this one, I have a different counter. So I call this the middle after. This is the middle after whatever the range was when the last robot's right shot. So I move the wall right index. This is the other index for the last wall that the previous robot shot rightwards. When it shot rightwards. So the last wall there. I move that index up to the position of the left. It could technically not move at all if it's kind of already overlapping. And then while the position of that rightward shot is not at the robot's position, then keep on incrementing. So this is the middle after count of walls destroyed. So then, to summarize here, if the current robot shoots left, then the most walls that can be destroyed would be if the previous walls would be the count of the previous walls destroyed if the last robot shot left, plus whatever middle walls was destroyed. Or if the previous robot shot right, then the walls destroyed that way, plus whatever walls are destroyed after if the current robot shoots left. And regardless, both of those will use wall left as the last index of the wall was shot, as if the robot shot left. And then similarly, or more easily, is the post value. Post value is for if the current the robot shoots rightwards. It's just the number of walls that are stored with that shot. So yeah, just increment have call. I use post as the counter for the walls there. And if it shoots rightwards, then it either takes the left destroyed plus post or the right destroyed plus post, because both of those are not going to necessarily interfere with this one. And then store both the count of walls destroyed that way and the index. Change the previous to current, and then just loops again and again. And eventually you get to your last thing, which is your maximum of the walls destroyed, where the current, which is the last robot, shoots left, or the last robot shoots right, and 0 is just the index of the walls destroyed, rather than 1, which is the index of the walls, plus the number of walls that are automatically destroyed. And then, so that was, with all that, I think it was okay-ish. It was like a decent amount of time. Without some of the optimization of the changing the DP matrix into a single kind of set of tuple values, 2 tuple values, that was a little slower. Anyways, summary, this is kind of dynamic linear, with which has some space optimizations. Namely, consider like 2 robots consecutive, and how to track the most number of walls destroyed for every combination of left or right shot between them, and then update appropriately. Again, there's just a bunch of optimizations here that I did. I don't know that they're necessary, or I'm sure that other methods would find kind of faster ways of doing some of the things I did. Yeah, I kind of did a lot of data massaging, changing the input values to something that is more parsable than my code, like changing the robots to be a tuple of left position right bounce. With some data massaging to change the format of the info to something more readily kind of parsable, analyzable, easy analyze, easy return. Time complexity looks to be O of n log n, since sorting the positions was necessary, after which it was O of n to iterate over the earliest to latest position robots to determine the maximum number of walls destroyed up to each. Space complexity is O of what? Oh, sorry. So that since created some temporary kind of alternative info array, basically the tuple arrays, to make it easier to parse. In theory, this could be done in O1 kind of in place. Yeah. All right.